Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 117, maximum spending after buying items. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Yeah, so this one, it's a hard problem, but I think Q3 was harder to be honest. But the tricky idea here is to think about it in a way such that, the short answer is going to be greedy. Why is it greedy? Um, why is it greedy is a very hard question to answer, and I think that's the hard part. And to be honest, I end up taking about 9 minutes. I probably could have done it much faster, if it was just solving the problem, I could have done it much faster. But it was about the proofs, and I spent a long time on the proofs, right? And speaking of greedy, this is going to be the proof. The greedy is just to take the smallest. This is not the proof. This is the code. This is just going to be taking the smallest item at every time. The short reason why you can do this is because everything is sorted, right? Because one of the things is that if you have like A, B, C, D, F, whatever, right? And I reversed it so that the smallest is in the front. I don't know why they kind of did it in a weird way, but in any case, yeah. So sorted means that we have A, we put A and the D. The smallest is going to be keep going, right? And because of this, because everything is sorted within the thing, and if you're popping it one at a time, essentially you're sorting the entire matrix, right? Or you're gonna be doing it in a sorted direction with the entire matrix. So you actually don't even need this heap, now that I think about it, because you're able to traverse the entire matrix in sorted order. Because for example, the only way that you could maybe think about it, maybe not, is if doing this and this would, if doing A and B, there's almost like an exchange argument type thing, is that if you do A and then B is worse than doing D and then A and then B, or something like some combination of that, right? So that's part one, is that you can sort the entire thing. So actually you could rewrite this pretty in an amusing way. Is that, and I'll do that right here, I suppose. Right? Because then now that I think about it, I can do this like very quickly, right? So I don't even need to all this confusion, right? Just go right? For index x in enumerate. And just total, right? So yeah, but so the question is, why does this greedy work? And right? The answer is actually because of the multiplication rule by day. I don't have a strict proof. Strict proofs, I don't know, not my forte. So, so it's gonna be tough. But the idea is that when you take a smallest element, what does that mean? That means that basically you make another copy of all the numbers, right? And because of that, you always want to take the smallest number. And because of the other principle that we just talked about, meaning that you can always traverse the entire matrix in sorted order, if you can always take the smallest number, then you can always be good. And this is because everything is sorted, right? For example, the only, like, if it is not sorted, you could have something like, right? Something like this maybe, right? If it's not sorted, you can, where you really actually want to, I mean, this is a bad example, maybe but something like this, or maybe this is a one, right? A lot of ones. Like something like this, and maybe this is not the right constant, but But there is a case eventually where you want to take 1,000 and then take all the ones over taking it this way. But because it is sorted, this is not a possible case, so that you can always take the minimum element from the values, right? So as a result, and you can think about it like every day that pass, you add another copy of the remaining elements, and because of that, you always want the smallest thing, because also the exchange argument, right? Because basically, let's say you want to do a comparison between the A, B, and then like rest, right? So you either take A, and then you get the value of A plus B the rest times 2, right? Or sum of this, right? Or B plus A plus rest times 2, right? And here, because we know that A is less than B, right? Or equal to, but for this purpose, we'll just say A is less than B. If A is less than B, then this will always be bigger, right? For obvious reasons. So that's like almost like an exchange argument type thing of like, hey, if we make this exchange, it doesn't make sense. And therefore, that is kind of roughly the proof. Yeah, that's all I have for this one. You could see the contest code next. I did think about using a heap, but I didn't think it one step forward. That would have solved a lot of typing, but I mean, it was pretty fine. But yeah, because of the sorting, this is going to be n-log n, both this and the heap. I guess the heap code is actually technically faster because the way that I did it now, even though it's faster to type, is n-log n. With a heap is going to be n-log 10 or n-log m, where m is the number of shops. So I guess that is faster. It is the same as like what you call a funnel sort or like a merge sort, right? So basically you have a merge sort thing, so you can reduce it from n-log n to n-log m, which is faster. So this is actually suboptimal. We'll go back to the other one then. Fine. A lot of undos. Okay, we will just go to that submission. Right. So yeah, so this is actually n-log m, so I guess that is faster and that is pretty nice. In terms of space, both of these is going to be O of n because you need to sort. Yeah, that's all I have for this one. Let me know what you think. You could watch me solve it live in the contest now. All right, let's give it a submit. I cannot do Q2, but I did Q3. All right, maximum spending after buying items. Okay, let's see. I'm going to do Q2 last because I'm a dummy. All right, you have a matrix. This is so hard to read, especially after my brain's fried for that one. Okay. Okay. There are a lot of different items in different shops. Each shop has n items, and the I've shop has okay. Additionally, the items are in non-increasing order, so they're decreasing order. I mean, they're equal. They could be equal. Fine. Monotonically decreasing. Okay. Pick any shop I. Buy the rightmost item J. For some D. What is D? Oh, on diff day. Okay. So why is it sorted in non-decrease? Because it feels like you can just do it in you could have done it you could just reverse everything and then do it the other way. What a silly way of writing this. Anyway, okay. Seems like the values, what's M again? M is different shops. Seems like a dynamic programming, right? So basically you want to do, what is the dynamic programming look like? You want, well, shop, so index on the shop, and then how many items to buy, maybe? What is the D again? What? How many days do we get? Oh, because I see. Basically, you want to buy all the items, but you want to do it in some way. Also, everything is reversed. I don't know why they do it this way, but okay. That part's not that important. And you could change when to buy an item. So actually, I mean, I don't know if it's DP, or I don't know. It's definitely not this type of DP. So I take it back a little bit. Do they intentionally do it this way, where the? Oh no, okay, they do overlap. Because that's just like a really confusing way of doing it if you cannot like. Okay. Is it greedy? Can it be greedy? Basically, okay, so you have a total of the array. Every day that you don't buy, the 10 items could be interesting, but or 10 shops rather. Every day that you don't buy, basically the total increases, right? So is it greedy? I mean, it is greedy if you can choose any item from every shop, but not necessarily in this way, maybe? Do we want to sort these? Because you can have a big one and go down the wrong path. Can you go down the wrong path? If we do it in reverse. No, because everything is in increasing order, right? So by definition, is that true? And what do you do about tiebreakers? Well, tiebreakers, it doesn't matter because you just do all of them in the same day. So if you, because they are sorted, you're always increasing, right? So maybe it's just, Then why is it 10? Is that true? Am I? Because it is, I mean, increasing, whatever. They do the order in a weird way. I mean, okay. I think so, but maybe I'm wrong. All right, let's try it. We want the smallest value. Okay, that's fine. Day one is just one, right? Okay, fine. Index, shop index, and then just index maybe, right? And then and then if index plus 1 is less than length of values of index, then we put it back. Values of is it no mod or anything? I mean, let's YOLO it. I mean, the important part is because yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest and problem. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.